Hi, I will talk about the packaging methods which we are applying at OpenPrinting so that we have sandbox distribution independent packaging. So the motivation is the following. We have several the distros, and the distros, they have their own packaging method. Most of them are somehow derived from Red Hat or Debian, and so they have RPM or Debian packaging. But these packages are they are specific to a certain distro and to a certain version of it, because the packages contain only usually some software itself and not the dependencies. The dependencies are in other packages, and each distro version has naturally different libraries and desktop versions and so on, and therefore they are highly dependent on the distribution. And this is also these packages, they are created by maintainers of the distribution. So to get new versions into the distribution, one is highly dependent on the goodwill of the maintainers of this distribution. And also we have the case that when you have a certain distribution, if you want to have the most end user, the ones which are really done for the end users, these are more the long-term support distributions, and they then have a release cycle of 2 years or so. And with this, components are 2 years old, and so it is not very easy to get the newest software in. And when you compare this with your smartphone, you see that in the smartphone you have the App Store and you can always install the newest applications. And so at OpenPrinting, we want to give the possibility to our users that they can get access to the newest software more quickly, especially if you have a printer which needs a printer driver, a legacy or specialty printer. Then you could depend on new versions of the printer driver, and then you would like to install the newest version of the printer driver, which your distro is perhaps not providing. But we at OpenPrinting are providing printer drivers inside the printer application packages, and we are frequently updating them. And so you have more easily the newest drivers there. And another thing is, sometimes you perhaps will also want to have the newest cups, which we can also provide directly from OpenPrinting when your distro does not provide it, and therefore we need, and for this we do distribution independent packaging. And what's on? What happened? What is happening with the image? Yes, we are now without the slides for some minutes, but what I want to say is that to solve the problem, more of the motivation of this problem, perhaps one or another has already heard yesterday from Jordan with the dilemma of distribution packaging. We solve the problem also with distribution independent sandboxed packaging. But we are not using Flatpak, as CUPS is a daemon, and the printer driver packages are also daemons. They are emulations of driverless IPP printers, and these are also daemons. And daemons you cannot Flatpak. And therefore, we use other distribution methods, other sandboxed packaging methods. And one of them is Snap. What is that? Now we know why we don't have the images, because it seems that in the director's room they use the wrong operating system. And yes, and so then, yes, we have, it comes back. We use Snap. This is a sandboxed packaging system. It's more universal. It can not only package desktop applications, but also system components, daemons, even the kernel, and so you can make a Snap-only operating system. And we also use OCI containers. We create OCI container images, which you can install. This gives additional flexibility, as once there are distributions which do not support Snap or do not support very well Snap, or you have server environments where it simply fits in better to work with OCI containers. So we are also making OCI containers. And perhaps also AppImage we will also not use because it has no security concept, and is also not good for system applications. And now we come to Snap. My colleague Soumyadeep Ghosh, who is part of the Snap Crafters, an organization making snaps of applications where the upstream is not snapping them. And so he has experience in snapping, at least desktop applications, and he will explain now, give now an introduction into Snap. So, Soumyadeep, do you hear me?
Am I audible?
Yes,
I
we
can
hear you.
Till.
Yes.
Okay, so hello everyone. Till has already introduced about me. I'm Soumyadeep Ghosh, part of Snap Crafters and Ubuntu community. So, do I need to share my screen or like the slides are already visible to the audience? Yeah, thank you. So let's talk about snaps. Like, what are snaps? We all have Android apps. We all have used Android apps, and you have the idea of how they work, how Google Play Store you go, or any other, or if Droid or this kind of Play Store, this kind of stores you go. There's one centralized store. You go download apps and just use it from there. So Snap is a similar solution for desktop. A plus point of snaps is that, first of all, it works on any distribution, on any Linux distro that's available, and also it's secure. It's secure in the sense that it's completely immutable. That is, the apps itself, that those are completely immutable, and you cannot really this is the security part. I'll talk about it in the next slide, but it's basically like this is what we call sandbox packaging. These apps runs in their own security shells. There is a completely separate isolated shell that the apps run. And as said before, the Snap Store is the centralized store having the complete control towards which snaps are allowed, which snaps are not, and thus the plugs or the permissions that these snaps use are also controlled by Snap Store. Like, for example, if some snap wants to use something related to system or related something to system that is not really very secure, those are not always explicitly granted by the Snap Store, and the users may need to manually connect to the permission, or maybe the developer needs to go to the forum and request for an auto connection, and that's how the security interface, the security system is defined. And of course, the plugs which or the permissions that I'm talking about, what are these? Like, these are very well curated, very well defined interfaces. Like, for example, desktop plug. The desktop plug gives access to various different files that are needed for a desktop snap to work. Like, for example, for an example, like a recent introduction which I fixed for the KD snaps was to be able to read the KD globals file in .config. So that's given access by the desktop plug. The GTK related files, the deconf related files, all these access are given by the desktop plug. That's how these plugs or these interfaces are defined within Snapd. Coming to the next slide. Next slide, yes. So what are these snap files? Like, these snaps are basically GPG key assigned by GPG key, and these are read-only file systems. These are read-only squash-face file systems that are actually mounted in your system during the boot up. So you don't actually have, like, the snaps. When you download a snap, a .snap file, it gets downloaded in your system, and then you install it. It installs as a loopback file system within your current setup. So like, it never really extracts the file. So the size of the snap is exactly what's the size of the snap is when you download it. There is no extra size. There is nothing extra when you need it. And all the metadata that the snap has, these are always, like, these are already within the snap in a snap.yml file, or sometimes manifest.yml file, depends on how the snap is being built. But generally, all the metadata are about the snap are written in a YAML file. And like, as Steele already said before, that there are different kind of snaps. Like, for example, a base snap that's basically kind of a wrapper. Like, it contains everything. The application snaps, which we generally use around for, like, for general purpose use cases, we generally do this kind of snaps. And of course, OS snaps, the Ubuntu core, for example, the gadget OS core snaps, gadget snaps, kernel snaps. That's how we in Ubuntu core we are able to snap the complete kernel. And of course, desktop stations, we have been able to create GNOME and KDE desktop stations with it as a snap. And as Till said again, daemons, we have snaps for them too. And one of the best things about snaps is its snapshot capability. Like, for example, you have an update of Firefox. You are, like, a lot of your work are around Firefox, and you need to make sure that the next update is very stable and secure, and obviously works for everything. Like, if for every purpose that you use your snap, the next version works perfectly for all of, like, and perfectly serves all the purposes that you use the app. So you update it and you saw that, okay, this thing is not working in this version. You can easily roll back to your previous version, to your previous to the previous revision of the Firefox snap, and get your complete, like, get the app just like it was before the update. One of the best things, one of the like best features about Snap. And yeah, binary dips, like, this is something that really helps about whenever there is this new update. So instead of downloading the complete binary from the store, what Snapd does, it calculates the binary diffs, it calculates the deltas, and it downloads those necessary changes, and thus it really helps with reducing the bandwidth, with reducing the files that need to be downloaded, that need to be stored. And regarding regarding availability in distros, well, of course, Ubuntu has support for it by default from 14.04. Other than Ubuntu, Snaps is supported in Debian, KDE Neon, Manjaro, and Zorin, and various other distros. There are multiple distros that currently support Snaps, and various other distros also the support is worked on. Next slide, please. So how the snap confinement works, like how snap is able to confine all the files and all. So the first layer of confinement is app armor. That's where all these rules of reading this file, reading this, accessing this debug, or accessing this binary, or accessing something from the system is permitted, like, or given. Like, for example, as I said before, in my previous example, I talked about the desktop plug that allows snaps to read gconf related files or KD's theme related files. These permissions are given by AppArmor. Uh, every single snap that is installed in your system, except the classic snaps, there is always a AppArmor profile that is generated by Snapd based on the plugs that are defined within the snaps manifest. So based on those defined plugs that are in the snap, the Snapd generates this AppArmor profile and it installs in your system. So every single snap has its own well defined AppArmor profile. Next comes to seccom, that like restricts which system call is allowed and which is not. So one might often notice that some random system calls are being restricted inside Snap. So that's due to the seccom profiling. And of course, separate namespaces. Every single snap has its own separate namespaces, so own PID, its own resources, everything of its completely separated from the actual system. And now this is a very interesting thing that many talks about Snap, that snaps can be run as root and it's insecure and all. Yes, snaps can be run as root, but it cannot break the package confinement, like, because there is no need for a specific user or for a specific group to be set up for the snaps to work as root. And this is like the perfect example of this are the daemon snaps, which Till will talk about in later. And in my previous slide, I told about binary difference. I told about how snaps are mounted and not extracted in your system. So this comes to a part where, like, the images are always compressed after installation. The squashfs file systems are always compressed after installation. Maybe it can use the exe compression or the L0 compression, depending on the compression that is generally defined inside the Snapcraft's manifest. It's in general, the L0 compression is now preferred over the exe compression, and that's why a lot of less of storage is being used. And another thing that helps the storage being like the storage efficiency is with the core snaps. Core snaps are the base providers that contains all these glibc files, all these very necessary dependencies that every single app needs to run. And this is something that was later introduced to help as a dependency system, but also not create a hell of a dependency. So these are called contained snaps. So these are basically snaps that just has the libraries, and these snaps provide slots to connect. And when connected, these contained snaps are mounted within those application snaps that are trying to consume these contained snaps. And these libraries then can be shared between n number of snaps. And that's how one can easily create shared library for any library or any binary. Like, for example, at Snapcrafters, we have created shared libraries for WebKit GTK. We have created shared libraries for FFmpeg, and this has really helped a lot of snaps being like super storage efficient. Like within 5-6 MBs, we are able to snap a app that is using WebKit or that is using FFmpeg, because this FFmpeg and WebKit libraries, these are being shared by multiple snaps installed in your system. So less storage being used. And now we are going to talk about how the cup snap works. So next slide, please. So basically, the cup snap, it works via these well-defined interfaces that are defined within a snap's manifest. So cups has a lot of plugs defined as well as slots. So what are plugs? A plug has to be connected with a slot of the system or another snap. Like the cup snap itself exposes a lot of slots. So and other snaps connects with this slot. Other snaps define plugs that connects with these slots in order to communicate with cups. So what are these plugs? Like these are as explained before. These are very well defined AppImage profile. These are very well defined AppImage rules, and of course like these are mediated through Snapd. So plugs, snap like safe interfaces which doesn't really harm much. Like for example, the cups plug that just lists the available printers in your system, and these kind of plugs are auto connected whenever you download your snap from the snap store. And then comes the dangerous interfaces. So, for example, cups control, or for example, password manager service. These kind of plugs, they are something that is kind of destructive. Like using this kind of plugs, destructive things can be done in your system. Like for example, if a snap gets access to your passwords, like that you don't want, that's not really something. Like for example, a malicious snap gets access to your passwords, or a malicious snaps removes printers from your system that you would not want, right? So you would like to give like to give those permissions to those snaps that you really trust, or the store itself, store team trusts, and the publisher is being vetted by the store team. And that is where the manual connection comes into the picture, and the permission of these snaps are that's how like maintained and controlled by the snap store team to to allow which snap will get the auto connection and which snap will not be given this auto connection. So yeah, next slide please. So now coming to the cup snap. So cup snap is basically the complete immutable printing stack of the cups ecosystem. Like it contains all the necessary components: cups filters, Ghostscript, QPDF, cups browser D, all this every single important components of of the printing architecture is snapped within one single snap, that is packed within one single snap, that is cups. So the cup snap provides these two slots, that's cups and cups control. So as explained before, cups is basically the cups slot needs to be like whenever a consumer snap wants to consume the cup slot to list the available printers, to read the list of available printers, it needs to connect with this slot that is provided by the cup snap. And there are various different plugs that the cup snap uses to communicate with systems, like the network interface, like the network bind interface, raw USB interface to read all the printers that are connected by USB, and Avahi control, and the system user and system group. Like instead of using the default LP as the group, the snap daemon is used as a part of the Snapd's sandboxing methods of mitigating the root user group, which will be explained by Till later in later slides. Next slide, please. So cups control gives a full admin access to the cup setup. Like cups control, as I explained before, like you can remove, add any printer to the current queue, and the snap mediation where the cups T allows admin access of from a snap only to its only when the snap is plugging with cups control plug. And this plug that's why is considered dangerous, because it has the capability of doing destructive things in your system. So that's why this will not be auto connected whenever snap uses this plug, and it needs to be the auto connect permission needs to be requested in the Snapcraft forum. And the cups interface, like this is the printing only access to the cups backend. So this interface, by this you can just print, and nothing destructive can be done through this interface. This also requires snap mediation to work, and that's why we currently force the use of cup snap, like because the snap mediation is done This is very secure to be to print. This is very secure method to print, and that's why this bug is always auto connected. So more on the club snap will be explained by Till. So over to you, Till.
So now Soumyadeep has explained what snap is and how the cup snap, the currently available cup snap, which is of cups 2.x, is working, and cups 3.x is under development. The lib cups for cups 3.x is nearly ready, and by the end of the year also we will have the new cups daemons for cups 3.x. And cups 3.x, the main differences are, once cups 3.x does not support classic printer drivers and PPDs anymore. It is IPP only. Only driverless IPP printers are supported. And the other thing is that the cups daemon is not one daemon anymore. There will be a local server, which is a user daemon, means it runs as the user who is logged in with a desktop. And this daemon is only for local printing. It discovers the IPP printers on the network and on the local machine also, and makes them available. And you can print with, for example, with your desktop applications or with the LP command, you can print locally. And then there's another daemon, the sharing server. This is a system daemon running as root and opening the port 631. It is for sharing printers. So if you want to share a local printer so that other people on the network can use it, then you need the sharing server. So we have the two servers, so most users will only have the local server installed, so they do not open a port on the network. They have not this extra process running as root. And now for the snapping, this means we do not have one cup snap anymore. We have two cup snaps. One cup snap will be for the sharing server. This will probably directly be derived from the current cup snap, because our current cups daemon is a system daemon sharing printers, and so it is probably the easiest way for the sharing server cup snap to use the current one and continue it as the sharing server one. The local server will be a little bit different, as it is a user daemon, which could probably run in two modes. One mode would be on login it is started, on logout it will get stopped. And the other would be that one can trigger it. And Mike's Suite is also adding to the possibility to access it. The local daemon will once be accessible as before by a Unix domain socket, but Mike plans that in addition it will be accessible by dbus, and so one could trigger it, probably with both modes. One could trigger it on demand, so that it's not actually running normally, but when a user wants to access printers, then the request coming from the application to list the printers to print a job will start the local cups daemon, and when the print job is done after a certain timeout, the local cups daemon will stop automatically. We must see what is better for the snapping and how much a permanently running local server of cups will need of resources. And then we need and then the snapping, the creation of the snapcraft.yaml file of the helper scripts and so on for the snaps. This is also managed on OpenPrinting's GitHub. Currently it is managed in the separate repository named cups-snap, but we are looking into soon moving it into the CUPS, into the CUPS upstream repositories itself, either already with CUPS 2.5 or at the step at the transition to CUPS 3. So now when we want to switch to the CUPS snap as the print environment of our system. For example, we want to have a system, an operating system, where we have always the newest print environment from upstream and are independent of the distro maintainers. Or we have an operating system which does not come with a print environment. There, one possibility is to install the CUPS snap, and the CUPS snap provides the print environment for the system. And for this to work, one has to take some things into account. One thing, the CUPS snap, the CUPS installation of the CUPS snap is done by an immutable file system, a read-only file system. You cannot add files to it, so you cannot add a driver. You cannot put into the file system of CUPS, you cannot put a driver filter and a PPD file. So with this, we get in a similar situation as we would also get with CUPS 3.x. We cannot add classic printer drivers. So we have, as we have for CUPS 3.x, we have to use printer applications, which are emulations of driverless IPP printers as drivers. Printer applications are available for all the free software drivers, so it should be no problem, at least for all the free software drivers. They are all in the Snap Store, and when you have decided to use the CUPS snap as your CUPS for the system, then it's also no problem to install printer application snaps to get drivers if you have an old printer. And we have drivers for around 10,000 printer models, the ones which come typically with Linux distributions. They are all in 4 printer application snaps available in the Snap Store. If we have a driver which is not under these which are available as printer applications, or for example it's a proprietary driver which we cannot redistribute at OpenPrinting, there is an application named Legacy Printer Up, which is part of the repository Puppel Retrofit, and this application looks into the classically installed system. The legacy printer must be classically installed, you cannot snap it. Looks into the classically installed system, whether there are classic printer drivers, and maps them into a printer application. So these classic printer drivers, which are classically installed on the system, are available then as printer application, and so the snapped CUPS can use them. And another thing is, if you have a printer setup tool and you have the snapped CUPS, you can, due to the fact that the snap CUPS cannot use classic printer drivers but has to use printer application, the add printer functionality of the printer setup tools does not work when you use the CUPS snap. But due to the fact that we are soon having CUPS 3.x, we are naturally already working on making the printer setup tools supporting printer applications. And another thing is the CUPS for the print dialogues, the CUPS snap is no problem. So because the CUPS browse-D, which takes care that IPP printer, one problem we had with the print dialogues and CUPS can use an IPP printer in the network without you creating a queue. CUPS would create a temporary queue. But such printers, many print dialogues do not list because they use the wrong API of CUPS. And therefore, years ago already, I've created CUPS browse-D, which automatically creates permanent print queues and cups for every IPP print destination which is detected on the network. And with this, then the printer applications list all printers automatically. And the cup snap of cups 2.x, which we have, contains cups browsed, so you see no difference on print dialogs, they just work with the cup snap. And Snap has one special thing. One can make an all Snap distro. This distro exists. This is Ubuntu Core. In this distro, there the kernel is a Snap, the base system, so the basic utilities and so are Snap, the boot system, the systemd and grub are another Snap, and the applications are also in Snaps. This was originally created for IoT and for servers, and currently is under development to create also an Ubuntu Core desktop, so Ubuntu Core with a desktop. And such distros, they would naturally use the cup snap to be able to print. And to do this, first, for having the complete printing stack, we need the cup snap. We need the IPP USB snap. This is to support IPP over USB. If you have a modern driverless printer and connect it by USB, it is not only driverless on the network, but also driverless on USB. When it is connected, when it connects via the IPP USB daemon, and then you see the printer's then the printer appears as a network printer on localhost port 60,000. And we also need, but this snap is not completed yet, the CPDB cups backend snap. This is a snap which contains a backend so that modern print dialogues can communicate with cups. And then, and with this, we have everything for driverless IPP printing. And for drivers, if we have an old printer or a specialty printer, we use printer application snaps, which are all in the Snap Store, as I told earlier. And so, in applications in such a distro, they have to plug the cups interface to be able to print. They could also use the common print dialog backends as soon as we have the CPDB cups backend snap already. But snaps can also use the portals. So they can also print through the XDG desktop portal, because this portal can also open the print dialog from the desktop, and so they also print this, can also print this way. But we are always we always recommend that an application snap should support all these methods, because this gives most safety that with very many different desktop environments and even without a desktop, the application can print. And then we have the printer setup tools, and they have to plug the cups control interface, as the cups control interface allows to create print queues, to remove print queues, and to modify them, and so on. And so we have now the printer applications. When you have a printer driver, I have already told that we cannot add a printer driver.
I'm so sorry to interrupt. We have started the break, and the time should have been over.
One thing is, it was told me that I can, or is the 40-minute time already?
Yeah, that's the 40-minute, exactly, I'm sorry.
So, yes. So, Should we, perhaps yes, now I did not come to the OCI containers. But if somebody has any questions,
I see that you still have like at least like 10 slides or something like that. Maybe you can continue the conversation in the coffee break, and if people online are interested, please feel free to send questions in the chat, and maybe you can continue the discussion about this. I'm so sorry to interrupt it, but otherwise people won't be able to get some coffee.
yes, yes. Another thing is also, nobody was here has shown the 10-minute sheet.
If you'd like to at least conclude what you were saying, of course you can. Of course you can do that.
Yes. One thing which I wanted to tell is that we also do OCI containers, which is another form of distribution-independent packaging, sandbox packaging. But this is something which is not so easy to use as Snap, as the permissions you have to define by the command line to start the OCI container. It is not built in as in Snap, but it works on more systems, because not all systems work with Snap. For example, for the security, Snap needs AppArmor. But with this, for example, you can install the print application packages on most of the immutable distros, and also on servers, for example. And at OpenPrinting we have also done, and we are shortly before publishing it, OCI container images of all components. And yes, here you see the very long and complex command line. You should write a script if you need OCI containers. And one thing is, as I said, Flatpak does not package daemons. There is some effort by Christian Hergert to Flatpak daemons, but they came up that systemd needs some changes, and these changes, I don't know whether they will be done or whether or not, and so on. And only then system components can be flatpacked. And then at OpenPrinting we will do that too. Yes, that's it.